Hey guys, welcome to my channel. So today we'll be looking at a simple deep neural network with like 2 layers. So I'm going to skip the first few steps when you're going to load the dataset. Please look at my previous videos if you want to know how to load the dataset as well as also pre-process those images. So if you're not following my videos, basically we're going to categorize cats and dogs. It's a binary classification. So now let's build a function with the model. So we can give in the argument for the number of layers. So let's say my first layer I want 64 neurons followed by let's say 16 neurons. So now let's build the first layer. tf dot keras dot flatten. So we are not doing any convolutional neural network, so we have to flatten the images. So our input shape would be mg height. So, and then we can also give a name to this layer. Since this is the input layer, we can put it as input layer. So I pre-process the height and width to be 256 by 256. So next, let's build the hidden layers. So we can just add upon the layers. So let's use least comprehension. So tf.keras.dense. Sorry, I mixed layers here. Layers.flatten. So here should be layers.dense. Then for the hidden layer, sorry, for the neurons, we can call them nodes, followed by activation, which equals to tf.keras.activation. Then we can use value. And then for name, we can use string. So as hidden dense. So H and O for the number of layers. For H and O nodes enumerate hidden. Okay, we can make it easier to look at. Okay, so now for the output layer, we're going to use the same way. Layers equals to layers plus tf dot keras layers dot dense. So I'm using argmax, which means I'm only giving out a single value. So for single value, I can have a last dense layer with just one output, and activation is going to be tf.keras.activation.signal. Since this is a classification problem, and then of course I can also give it a name. So name equals to output underscore layer. Okay. So now let's create a model. So model equals to tf.keras.sequential model, and then we can pass in the layers. And then we can call this model, name equals to cats and dog classifier. So now let's compile the model. So compile, and then we are going to use optimizer equals to tf.keras.optimizer.binary, sorry, Adam. Okay. Next log function is going to be tf.keras.losses, then case binary cross atrophy, and then we have to put logic equals to false. Since we have already defined an activation function here logic should be false. And for matrix, we can use tf.keras.matrix.accuracy. Okay, so now let's also clean out the model.summary. Okay, so before we train the model, let's review the summary. So the model equals to here shouldn't have any values. You can put the values here. Now hidden equals to 64 and 16. So let's see. Okay guys, so I found out the issue. So we have to instantiate the binary accuracy first before we put it into matrix. So once we do that, we can check the model summary. So we are getting the first input layer followed by the hidden layer 1 with 64 neurons, hidden layer 0 with 64 neurons, hidden layer 1 with 16 neurons, then the binary output of 1 for the output layer. So now once we are done with the model, we can now train the model. So we are going to history equals to model.fit. So we pass in the training data set followed by validation data, which is going to be evaluation data set for epochs equals to 5. So another step I forgot is to also put in the training and the evaluation data set. So we can put it before the first layer. And then we can put in a batch size of 10. For evaluation set, the batch size does not matter, so I'm going to put 1. So let's train the model. Okay, so the training has been completed for 5 epochs. So we can see that for training accuracy we are getting 0.62, and for the validation accuracy we are getting 0.59. So we have not added any regularization or any learning rate. Just with 2 hidden layers we got an accuracy of 0.59. So thank you, and please subscribe if this is useful. Bye bye.